Paper 1 explained. Question 1. The following diagram shows triangle ABC with AB equal to 9 and AC equal to 13. A. Given that cos A is equal to 7 divided by 9, find the value of sine A. If we drop a perpendicular from angle B to line AC, we will get a perfect right-angled triangle. So the triangle is ABD. We know that AB is equal to 9. We know that AC is equal to 7. So we can find BC using Pythagoras. So BC is equal to the square root of 9 squared minus 7 squared. So BC is equal to the square root of 32. If we rationalise that, we get BC is equal to the square root of 16 times the square root of 2. We know what the square root of 16 is. So BC is equal to 4 root 2. Therefore, sine A is equal to 4 root 2 over 9. B. Find the area of the triangle ABC. Well, the area of a triangle can be found using a half times AB times AC times sine A, which is equal to a half times 9 times 13 times 4 root 2 over 9. So we can do some cancelling. Cancel the 9s. We can cancel the 2s with the 4 to give 2. When we multiply that out, we get 26 root 2. That is the area of triangle ABC. Question 2. A. If n is even, show that n minus 1 all squared plus n plus 1 all squared is equal to 2n squared plus 2. Multiply out the left-hand side. So we get n minus 1 squared is equal to n squared minus 2n plus 1. N plus 1 all squared is equal to n squared plus 2n plus 1. If we add these two together, we get 2n squared. The 2n's cancel, plus 2, which is equal to 2n squared plus 2. Therefore, correct. B. Hence or otherwise prove that the sum of the squares of any two consecutive odd numbers is even. Well, n minus 1 is an odd number. N plus 1 is also an odd number if n is even. Therefore, 2n squared plus 2 is equal to, factorise the 2 out, 2 n squared plus 1. Therefore, because a multiple of 2n squared plus 2 is even. Therefore, proved. Question 3. the functions f and g are defined such that f of x equals x plus 2 divided by 3 and g of x equals 6x plus 2. Show that g of f of x equals 2x plus 6. You need to take the function f, and wherever you see x in g, substitute f of x. So therefore, we get 6 lots of x plus 2 over 3 plus 2. Let's cancel the 6 and the 3 to give us 2. So therefore, we now get 2 times x is 2x, plus 2 times 2 is 4, plus the 2, which equals 2x plus 6. Proven. Part B. Given that the inverse of g of f of a is equal to 5, find the value of a. In order to solve this, we put the value 5 into the inverse of the inverse, which is 2x plus 5. So therefore, we substitute 5 into 2x plus 6, giving us 2 lots of 5 plus 6, which equals to 10 plus 6, which equals 16. Therefore, a is equal to 16. 4a, show that log to the base 9 of 4x minus 3 is equal to log to the base 3 of the square root of 4x minus 3. In order to solve this, we're going to have to use the change of base rule. So log 9 of 4x minus 3 is the same as log 3 of 4x minus 3 divided by log 3 of 9. But log 3 of 9 is equal to 2. So therefore, we've got log 3 of 4x minus 3 over 2. Therefore, we've got a half log 3 of 4x minus 3. Bring the half as a power, so therefore we've got log 3 of 4x minus 3 to the power of a half. Power of a half is the same as square root, so therefore we got log 3 the square root of 4x minus 3. Proven. Part B, solve log 3x is equal to log 9 4x minus 3. We already know that log 9 to the 4x minus 3 is equal to log base 3, the square root of 4x minus 3. So therefore, we've got log to the base 3 of x is equal to log to the base 3 of the square root of 4x minus 3. Now they're in the same base, we can remove the logs. So therefore, we get x is equal to the square root of 4x minus 3. If we square both sides, we'll get rid of the square root sign. So therefore, we've got x squared is equal to 4x minus 3. Take the 4x minus 3 to the left-hand side. Therefore, we've got x squared minus 4x plus 3 is equal to 0. Therefore, if we factorise, we get x minus 3, x minus 1 is equal to 0. Therefore, x is equal to 3 or x is equal to 1. Question 5. let f of x equal 1/3 x cubed minus x squared minus 8x plus 10. A, find f dash of x. So A, the f dash of x is equal to x squared minus 2x minus 8. Part B, the graph of f of x has horizontal tangents when x equals a and x equals b, where a is less than b. Find the value of a and the value of b. Horizontal tangents have a gradient of 0. That means we need to find when f dash x equals 0. So therefore we get x squared minus 2x minus 8 is equal to 0. If we factorise, we get x minus 4, x plus 2 is equal to 0. So x equals 4 and x equals minus 2. Therefore, because a is less than b, we know that a is equal to minus 2 and b is equal to 4. C, part 1. Sketch the graph of y equals f dash of x. That means we have to sketch the graph of x squared minus 2x minus 8. We know it has roots at x equals 4 and x equals minus 2. Here is the graph of f dash x equals x squared minus 2x minus 8, clearly showing the roots at a equals minus 2 and b equals 4. Part 2. Hence explain why the graph of f of x has a local maximum at the point x equals a. As you can see from the graph, f dash of x changes from positive to 0 to negative at the point x equals minus 2, which means at that point f of x has a maximum point. D, part 1, find f double dash b. First we need to find f double dash. Well, f dash x is equal to x squared minus 2x minus 8. So f double dash of x is equal to 2x minus 2. We know that b is equal to 4. So f double dash 4 is equal to 2 times 4 minus 2, which is 6. D, part 2. Hence, use the answer to D, part 1 to show that the graph of f of x has a local minimum at x equals b. Because f double dash 4 is greater than 0, we know it is concave up, therefore x equals b is minimum. E. The normal of the graph of f of x at x equal a and the tangent of the graph of f of x at the point x equal b intersect at the point PQ. Find the value of P and the value of Q. First, draw a rough sketch of the diagram and draw in the two tangents. Here we have A, here we have B. If I draw in the normal at A, and it crosses with the tangent at B, this is the point PQ. The normal has the equation x equals minus 2. So I know the value of P is equal to minus 2. Q has the value of y for f of x at B. So Q is equal to F4, which is equal to minus 50 over 3. Therefore, Q is equal to minus 50 over 3. So the point PQ is the point minus 2 minus 50 over 3.